Okay, good afternoon, everybody. I'm pleased to have a few people to speak to, so thank you very much. Welcome. My name is Paul Hamblyn. I'm Director of TEDOM Group here in the UK, joined by my colleague Phil Greenbury, who's actually the project manager on the project we're going to talk about, Aston Manor Cider. So if you do have technical questions, Phil's our man. He's going to answer all those questions. So, as I've suggested here, we're going to talk about a case study particularly, and in this case it's a company called Aston Manor Cider. So what are we going to have a look at through this afternoon? We'll have a quick look at the background and context of the project. We'll talk about the drivers that the customer had. In other words, why was the project undertaken? We'll look at the process that we went through in terms of feasibility and then design. We'll talk a bit about the construction, the commissioning and operation of the project, and then most importantly, what was actually delivered in terms of the outcomes, what impact has it had for the customer, what lessons we can all learn from that process, and then a very small bit about us as TEDOM and why you might want to choose us as your partner in terms of delivering something similar for your business. So let's start with the background and context. So Aston Manor Cider, if you're not familiar with them, they're one of the UK's leading suppliers of what they describe as private label cider. So they make ciders for the supermarkets and other brands. They have 3 sites in the UK, one in Birmingham, Tiverton, which is the site we're going to talk about, and another in Stourport. Originally founded in 1981, I believe by Doug Ellis, if I remember rightly, who was the chairman of Aston Villa Football Club. But since 2018, the business has actually been part of the French-owned group called Agrial. Agrial themselves is a cooperative owned by some 12,000 farmers across France, but it has a very international reach. So particularly in terms of apple products, they have a cider manufacturer in the form of Aston Manor here in the UK, but they also have another one in the US, in Seattle. As a business, Agrial have set themselves some quite ambitious science-based targets, particularly to halve their greenhouse gas emissions by 2035. And that's a combination of both direct and indirect carbon usage across their portfolio of products. In addition to that, the site at Tiverton had a very specific requirement to remove its aged kerosene boilers. These were causing them problems on site, including some additional environmental pollution into the watercourse. And the EA had actually set them the goal of having these boilers replaced by the middle of 2024. So in terms of why they went on from that requirement to looking at the project, so on the site at Tiverton, they produce about 840,000 hectolitres of cider a year. And that whole process was reliant upon 2 aged kerosene-fueled boilers. Those boilers had some operational risks, principally because of their age. They failed often, they had these issues with leaks contaminating the local watercourse, and it was inherently an inefficient process and therefore consequently had a high carbon footprint as well. They'd already identified a desire to remove steam from their process and switch to low temperature hot water, and they felt that there were some other process enhancements they could make, particularly on their pasteurisation, that would enable them to get some benefits. Separately to that, Agrial as a business had ring-fenced 50 million euros to spend on carbon reduction projects. But that was done on a competitive bidding process. And in fact, Paul Clifton, the operations manager at the site in Tiverton, had to actually go to France to bid for this money in French. So he took this project to them and won the funding to actually undertake this project. So they were starting from a baseline of just over 3,300 tonnes of CO2 equivalent in terms of their baseline emissions. And so how do they come into contact with us? Well, surprisingly, through a chance encounter. We have another customer in the sector, Carlsberg Marston's. We happened to be on site when they were visiting to understand what they'd done on their site, and a conversation ensued, and that resulted in the project we're going to talk about today. So in terms of the feasibility, we had to look at three things principally. The technical feasibility of the project, the environmental feasibility, and then the commercial assessment. That involved a whole series of work over a period of months, and I'll just quickly walk you through some of those in a little bit more detail. So firstly, on the technical side, both the client and TEDOM as a company, we had to think about what was the best solution. There was a need to move away from kerosene. That was seen as a big advantage, and in doing that there were potentially a number of ways that that could be undertaken. So the most obvious is to think about the electrification of processes, the use of things like electric boilers and heat pumps, or potentially doing an alternative fuel switch to something like LPG or natural gas. We also looked at the opportunity for hydrogen as well on the site. And then there was this important requirement they'd already identified to move away from using steam and instead switching to low temperature hot water. The reason that was important was that actually on the site, most of the steam was already being converted into low temperature hot water for use in the process. So there was an automatic inefficiency in that conversion from steam into low temperature hot water, which there was an opportunity to eradicate. They also wanted to enhance their energy resilience on site, and by generating electricity directly on site, that helped them potentially to do that. But again, there was a range of different technologies that could be considered in addition to CHP. Things like solar PV, etc., were also looked at. Locally, it was uncertain what the local DNO was going to be able to provide in terms of grid capacity. But most importantly, one of the factors that also needed thinking about was that they have kerosene boilers. Why do they have kerosene boilers? Because at the time when they were originally put in, there's no natural gas in Tiverton. Although over the years that had been brought into the town, and we looked at the opportunity for bringing natural gas to the site. The next thing to consider was what were the feasibilities around carbon reductions. I've already mentioned what the baseline emissions were. It was seen that electrification potentially had the best benefit in terms of delivering a carbon reduction, but the application technically was difficult. Heat pumps weren't suitable, and other technologies were also going to be difficult to apply. And when we looked at hydrogen, the opportunity of actually obtaining green hydrogen into the process was extremely difficult. Those commercial opportunities are not readily available currently. And when we looked at things in a broader scale, it was very clear that actually switching away from kerosene to natural gas, bringing natural gas to the site and then deploying combined heat and power technology was a way of delivering lower carbon to the site, and we were estimating somewhere of around about a 30% emission saving. Commercially, we had to look at, in simple terms, what the return of investment was going to be on the capital that was going to be deployed. The project actually consisted of not just the CHP units. There was the need to bring natural gas to the site. Something like just over a kilometre of gas main had to be installed to bring that to the site. We had to remove the existing steam boilers and replace them with 2 high-efficiency natural gas boilers. There was the CHP unit that was an integral part of the solution, and then things like a thermal store to smooth out the thermal load across the operation of the site, and the need to renew the existing chimney stack and to replace that with one that was suitable for use with both the CHP and the new boilers. Ultimately, this was a total investment for the client of about £2 million. We forecasted a simple payback within 2 years. I'm going to show you at the end what's actually been delivered. We thought there'd be some other benefits as well. So, for example, we expected there to be some reductions in the climate change agreement buyouts that the site was having to spend money on. And by deploying CHP appropriately, we were certain we could get the exemption from climate change levy on the gas that was being used in the machine itself. So, the key challenges in terms of the construction was very much around getting that gas to site. Phil undertook that work, and you can tell us in more detail exactly what was involved, but effectively we had to dig a kilometre-long trench to bring that into the site. we had to decommission the existing large steam boilers in the same plant room where the CHP and the new gas boilers were going to be installed. We had to remove the existing flue stack and replace that. And most importantly, the client was absolutely insistent that there should be no stoppage in terms of production. Really pleased to say that we were able to achieve those things. Our scope of work included everything. So right the way through from applying for the grid connection for the CHP unit, through to the installation of the gas main that I've mentioned. The staged removal of steam from site was done in cooperation with the client's team as well. And then the removal of the steam boilers, the introduction of the gas boilers, and the switch over from steam to low temperature hot water. We had to manage that whole process, interesting process, in the middle of which asbestos was discovered on the site as well. Perhaps not a complete unexpected thing, but actually the challenge of building that 10-week delay into the programme is something that we had to overcome. What was excluded from our package was the client identified an opportunity to update their pasteurisation system. So they went away from using an aged tunnel pasteuriser to some new flash pasteurisation. They undertook that work themselves alongside this project. What I have here, if this will play, is a very short video. Yes, here we are. So this is the site. What you're going to see come up on screen is some of the work that was undertaken whilst the project was underway. This particularly is focused on the delivery of the 500 kilowatt CHP unit that was taken to site. As you can see, it's an existing building. We had to locate the plant into the existing building. That had to be undertaken, and I must stress this, whilst the site remained in production. And I think, Phil, I'm right in saying that at one point we had one of the two steam boilers still in operation at the same time as the gas boilers were being installed. It required a lot of coordination, but it can be done, and that's the important thing to remember. I need to try and find something else to say whilst the video finishes. And I think I just about got there. So it gives you a little sense as to some of what was involved in the project. So the project took roughly 12 months from start to finish, and that included the delay that I alluded to in relation to the asbestos removal. We initially commissioned the boiler system independent of the CHPs. That was to enable this switch over from steam to low temperature hot water. And then we introduced the CHP, achieved the G99 certification with the local DNO, and then basically fine-tuned the operation of the system so that the CHP was working in conjunction with the gas boilers. This project works because principally the CHP delivers all of the thermal energy that the site requires for its process. To achieve that, we're actually delivering availability on that machine of over 98%. The project was commissioned earlier this year. It runs 24/7. There is some downtime clearly for maintenance, but actually we've got very minimal run hours on those new gas boilers. And it is from the efficiency of the combined heat and power process that we're delivering the carbon benefits to the client. I'm not sure you can see on the screen, unfortunately it's not quite large enough, but that gives you lots of detail about the actual run hours that we're getting from the CHP unit. So if we now think about what's actually been delivered, if you remember back to what the client and the feasibility studies illustrated, we were expecting to deliver somewhere around a 30% carbon reduction, and we were expecting to achieve a return on investment or a simple payback within 2 years. So the project cost roughly £2 million in round numbers. Then the client has actually delivered a saving in excess of £1.1 million based upon the prices and tariffs they were paying in 2024. Clearly, as energy prices vary over time, the actual cost value will change. But given their initial investment, the project is on course really to deliver that simple payback within the 2-year period that was anticipated at the beginning. Importantly, the carbon reduction is actually very slightly higher than that we originally intended. So we've achieved a 32% reduction, so a little over 1,100 tonnes of CO2 equivalent is forecast for the full 12 months since the unit went into operation in January. As you can see already, we completely eliminated the need for kerosene on site. And that removed and mitigated the risks associated with the watercourse pollution that the site was experiencing up to that point. And as we anticipated, the climate change buyout costs have reduced basically to zero. So that's what's happening at Tiverton. If we now think about Agrial Group as a whole, if you remember back to the fact that they'd put aside a chunk of money, some 50 million euros, to fund these type of projects, well, this project alone has delivered 0.6% reduction. Now, that doesn't sound like a big number. It's not a great number, is it? But actually, it's quite significant in terms of the overall reduction in Scope 1 and 2 emissions that Agrial is delivering as a group worldwide. And what I'm really pleased to say is that actually this project, both Aston, Manor, Cider and us as TEDOM, we applied for this to go into the heat decarbonisation of the project of the year at the ED Awards, which are actually being awarded this coming Friday. So if I was doing this next Wednesday, I'd be able to tell you if we've won. But for the moment, we're just a finalist. But we're obviously optimistic that we'll still be able to win from there. So just briefly to sum up then, and to give you a sense of who we are. I mean, TEDOM as a business, we are a CHP manufacturer. We're also an energy services company. So we've talked here about a project where a company has actually purchased the equipment and they're enjoying all the upside benefits from that project and its operation. But as an energy services company, we can also fund, operate and maintain those assets as well. That means that you can avoid the initial capital investment up front and you simply buy the low carbon energy that we're producing. We have considerable experience in the food and drink sector, but as you can see from some of the other brands I've shown on the screen there, we also have a much broader portfolio of clients from the healthcare sector in the NHS through to retail and hospitality and lots of others in between. We really understand how food and drink works and how the manufacturing process works. We've been able to deliver this project whilst maintaining the site in production throughout the 12-month duration. Really important for our food and drink manufacturing clients. We can provide the complete service end to end, from feasibility through to delivery and then ongoing maintenance. And we stand ready to help you in your ambitions. In terms of products, please come and talk to us on stand 21. We can tell you more about the particular products that we have. I think what's really important to remember about the product offer is future-proofed. So all of our CHP units are hydrogen ready. So if hydrogen does come into the natural gas grid, even here at Tiverton, it will be able to continue to run on that blend of hydrogen together with natural gas. And I think that's it. So very happy to take any questions if you do have them, or alternatively, come and see us on stand 21. Thank you very much for your attention. Any questions? Phil needs to say something.
Phil doesn't.
You don't want to say anything? Okay, fair enough. I take it there are no questions. So, okay. Happy to talk to you afterwards as well. So thank you very much.